Okay, everybody, welcome back to 401 Test Engineering. This is week 2, and we're going to continue on with our project scoping and project planning. The last week you had the task of posting some ideas, not only for an assignment where you posted 3 different ideas for each of the impact areas that we're looking at, but you also posted an idea to the forum for everyone in the class to take a look at, articulating the impact that you're interested in working in, the test description, and the key question. And so we're going to carry on with that today. We're going to do a little bit of a group discussion in the beginning, and then at the end we're going to go through the next assignment, which is going to take us one step closer to a proposal and then a plan for your test engineering project for the semester. It's going to involve the experimental test plan, the Taguchi method, the Keen Engineering Unleashed framework, the Hallmeyer Catechism, and Analytical Thinking Guide as structures for project planning. And so today we're going to go ahead and start off by sharing with small teams. There's 5 TAs, so we're going to break everybody up into 5 small groups, and then you're going to break out with your group to talk about your impact, key question, test description, and then the impact statement. All with the idea that the impact areas that we looked at are environmental, economic, social or societal, and we're calling those green, good, green, gold, good, or gone. Green, environmental; gold, economic; good, humanitarian, social; or gone. We're not going to do it if it's not in one of those areas. Kind of a Clarkson kind of spin on the idea. So the projects need to fall within mechanical and aeronautical engineering and meet one of the statements for why we experiment. And those are listed here. So they need to actually be experimental tests, physical tests, not just simulation, even though they might be involved validating a numerical or simulation model. And then they need to pass a risk assessment. So we're going to go ahead and socialize ideas by breaking out into groups now. Let me get this.
Okay, so one of the 5 design ideas that we settled on was using a remote control car to improve current traction control systems, where the key question would be, how could we make cars safer using traction control systems and increasing the current design? More research would have to be done on what parameters we would do it by, like rotation speed or maybe suspension components, or some type of actual like feedback system from wheel sensors to like currently distribute rotational speed and compensate accordingly. We determined this would be a social impact area because it would have to do with people's safety. That operate the vehicle. And if anyone has any questions or comments, ideas. Cool. Thank you.
So our second idea was to create a more accessible, basically make wheelchairs more accessible and safer during extreme weather conditions. So it's really icy out right now, and we would create mounts that would go on the wheels that could be detachable or attachable. So, you know, it's more functional. And how we would do this is by comparing different materials and testing them out basically to see which works better. And this would help. This would fall under good for social.
Good. Jack, Mark, what do y'all?
So yeah, my idea was to try and develop a dimmable film that could be applied to automotive side mirrors. So in an effort to try and help prevent the bright lights from somebody behind you, blinding you. And so yeah, I think the test procedure would be to try and either make something ourselves or maybe test things that do exist, because there are dimmable films that do exist. They're just not used in this application. Yeah, so I think there was an app that Professor Hoover showed me in 201 called Firefox, and it allows you to use your camera sensor to detect luminosity or luminescence. And yeah, and so using that, we could have the film on a mirror and then reflect light off of it, have this sensor detect that, and change its transparency. And yeah, and we could see how those different changes can affect the or how well it absorbs the light. But yeah, and so the impact area would be social to help make cars safer. So yeah, that's my plan.
All right. Hi, guys. I'm Jack. So one of my ideas was with brake rotors and race applications. So for those that don't know, they're commonly drilled or slotted for weight reduction and added cooling effect. But obviously, at some point, you're removing the majority of the brake material and you kind of lose that benefit, and you decrease the amount of braking that you can do with that rotor. So my key question is, how much of that material can you remove without getting rid of the added benefits of it and still being able to brake effectively? So my test plan, they would have some sort of braking apparatus where the RPM, braking force would be constant and set, and we can measure the time it takes to stop the rotor, the heat, and there would be a series of rotors, and each one would have a different amount of drilled holes. You could do that in a uniform pattern or test different patterns and see how that work. And kind of come up with some sort of ratio or range where it is optimal. So as far as impact area, I thought this would be gold. So environmental. So for automotive manufacturers, how to save materials, race applications, how to save on weight and save on budget. So yeah.
So one of the ideas that we were talking about was a common train engine component for the cooling system is that it is water cooled, and in colder climates, when the train is idle, that tends to freeze up and cause freeze damage. So something I've been working on for a while is, I guess the key question would be, how can we detect the temperatures within that cooling system without having to make any changes to the pre-existing engine or cooling system. So my idea was we could attach thermocouples to just a piece of cast iron and code a way to get that data input of the temperature of the cast iron, and then see if we can compensate for the thermal conductivity of that piece of cast iron to detect what's inside of it, like that temperature. And then the main goal would be to then have it notify the railway managers when their coolant system has reached critically low temperatures, so they can act before it freezes and causes any damage. So that would be both a green and gold impact area, because currently a lot of railway managers are just keeping their engines on but idle to keep it warm to prevent freezing. So that kind of wastes a lot of energy. And also to prevent overhaul, that would save a lot of money for the companies. So yeah.
Especially appropriate on daylight today.
Yes, for sure.
So my idea was to create a composting method in order to obtain the methane that is created as a byproduct of decomposing, in order to use that methane to cook your food. So so in order to do this, we have to kind of like make an enclosure, start doing some composting, and like we will have to figure out what types of food scraps will be produce the most methane. And then we also got to figure out which, like during which day is it the most efficient, or what a stage of the decomposition is it producing the most methane. So then, and then all of this will be, once all this methane is collected, we could mix this back with the other natural gases and use that to cook your food. So this is sort of a little bit of green and gold, because then gas company, or you will save money on it. And it's also a little green because you're eliminating food waste that just gets sent to landfill, which is not really be using for much. Yeah. Any questions? Okay.
Hi, so I'm Elliot, and our design, we had an idea for like a variable geometry wing that's able to change its airfoil for like takeoff and landing. And that was kind of like our key question, like, is it possible to design it, and what's its efficiency? Is it more efficient than like a traditional flap system? And for our test description, we'd probably use the wind tunnel and probably do like flow visualization to watch like the effect of drag and like the turbulent flows generated off of the trailing edge. And like the impact area was like environmental, because, you know, drag is costly. You know, if you can create as much lift without as much drag, you don't have to use as much thrust to fly the airplane. So it saves in the long run. But
Any particular geometry?
not really. There was a couple like previous designs that I've like looked and kind of scoundered over, but like one of them had like the whole trailing edge and like from like the spar box back like changes and is able to adjust its shape and in a pretty cool manner. So
Very cool.
Yeah.
Oh, yeah.
I'm Nolan. The other idea that our group picked was trying to optimize the geometry of computer fan blades to see if there's a better profile in order to use less power to keep and less power, but also optimize airflow. And another thing that somebody brought up was also decreasing the sound of fans, because if you get a lot of computer fans in a big server room, get a lot of noise, that's a problem. But I guess a test would be simulating different fan profiles and then actually taking a few of those ideas and 3D printing them and using them in the air tunnel. And then if you get a couple of good designs, you could make a actual fan and put it into a test computer and see which ones have the best airflow and the best like keeping the temperatures at a low point. The impact area would be both good and gold, because good, keep your computer parts at a lower temperature, keeps them safe. But gold also, you could use less power to keep them at a desired temperature and use less money and power.
Kind of thing has a huge impact when it scales out.
Oh yeah. Yeah, I've been in a couple server rooms and you can't hear anything when you're there. So
I have an old Alienware laptop that has a fan that like keeps their. Andrew, is that you? Good. Raise your hand again. Oh, Dave. Yeah. Okay. Sorry.
So what we picked was studying aircraft flutter, which is basically oscillating wings during certain aerodynamic conditions. So the test procedure was probably going to take a model aircraft, put it in one of the wind tunnels, observe when those patterns happen and that like what angles of attack, what air speeds, and that kind of deal, and then try and develop structures that help produce it, kind of a deal. It's mostly a social benefit because it keeps aircraft safe.
Done deal?
Ali, you ready? Oh, come on. Go ahead.
So I'm Andrew. So a potential idea that I was thinking of was potentially to see if there's any fuels that can replace gasoline to work in ICE engines. So the idea is to test like existing biofuels right now that could work in an ICE engine and measuring out their potential efficiency. So like one test idea we could do is like use like a lawnmower, so like a small engine, and just test out by putting like using the biofuel and just testing out the potential like thermal efficiency and just the efficiency of the engine in general.
Say ice engine or nice?
ICE engine, sorry, like internal combustion engines.
Ah, okay.
Sorry about that. Sorry. So I was thinking this would be more of like a environmental impact, since it wouldn't, if we could find a biofuel to work in combustion engines, then obviously you wouldn't need the fossil fuels nearly as much. And we can also keep existing infrastructure rather than trying to redesign or like forcing people to go with new infrastructure. And I thought it was also be a bit of an economical impact, because people wouldn't have to spend money if we could find a fuel to get like electrical vehicles, since they're fairly expensive, or things like that. So.
Good. All right. Thank you. So that's our version of starting to socialize those ideas, narrowing the funnel for what projects that we're going to do in class. And so the next part of the class today is going to be giving you some preparation for what the next assignment involves. And so this is basically a set of tools or methods, frameworks to help you start looking at your problem or project idea from different angles. And so we're going to talk about the experimental test plan, the Keen Engineering Unleashed framework, and the Heilmeyer Catechism. And we're also going to start to introduce the risk assessment and the risk assessment process that that we're going to use in class. So I'll turn it over to TAs. You ready? Introduce yourself. Too.
Hello, everyone. I am Sandeep, and I'm a TA for 401, and most likely will be like advising you in some of your projects. So right now, let's discuss about, where is the, okay, yeah, give me a second now, let that go. Was that there? It was this one.
Here.
Oh, lab schedule, sorry. All right. So let's look into the experimental test plan. We have discussed this before as well, and I'm pretty sure all of you are aware of experimental test plan in one way or another. In this lab, for your project idea, you'll be using certain steps that are shown in the screen to basically like provide more details on your project idea about what is it about, how you want to do it, and how will you analyze the data and everything. You'll follow these steps. The first step is parameter design plan, where you will define your test objective. It's basically your key question, and you'll also identify the parameters and variables that will be involved in your project. Parameters are terms that most likely will remain constant throughout your experiment, and variables will definitely change throughout your experiment. Then you will talk about what kind of instrument will you use to perform your experiment for your project. What are the test procedure, what are the limits and tolerances, all these details about the equipments as well. Then you will start talking about how will you analyze your data, what kind of data you will get, what are your expected results, right? And then how will you use those data to justify the key question of your project. You'll discuss all of these things going forward for your project ideas, provide a detailed explanation. And all these things, they go hand to hand with each other. Like sometime when you're actually in your analyzing your data, you might need to go back and change some of your parameters, some of your variables as well, right? So you will relate, these things will relate to each other, and you'll know more about it once you start thinking about it in more detail.
Hey guys, I'm Shafat. And the next part you'll be working on is the answering the questions the Heilmeier Catechism proposes. So the questions are pretty straightforward. And the first question is the same thing you want to be, is that you want to be straightforward with your objectives, what you want to do without using any abbreviations or jargons. The current practice, how it's done today, what are the limitations that the current practice faces, and what your approach will be, what novelty you're introducing in your proposal that will make it successful and overcome those limits. Who cares? Who are your target audience and who are your stakeholders even? So you can kind of sense the idea that you're kind of moving on to the entrepreneurial side, like a business, putting on your business hats. So, you know, the difference that it'll make for both your target audience and the stakeholders. What are the risks associated? You always want to consider risks because as we'll talk about later in this presentation, we don't want to be in the critical risk zone. How much it will cost, so your budget for the for your project. So when you're thinking of budget, always try to think of the return on investment. So if your project is sustainable, then we can make sure like higher budget can be you know set to your project. Then the time it'll take, make sure to plan ahead. You need to do your tests, get your results, write your report all within this semester. So make sure you're always on track in planning ahead. One way to make sure your progress is you're on track is to have a midterm and a final examination planned. So tests that will ensure that you're heading towards your aimed goal. That said, I'm going to hand it over to Amir, who's going to talk about heat engineering.
Hello, everyone. My name is Amir. In this slide, I'm going to exploring the framework. First of all, there is a question here. What's missing from design? As you can see, there are two other parts, opportunity and impact. Design without initial exploration and an eye for impact doesn't create the best value for you and society. By adding opportunity and impact to your design skills, you will be able to, for example, apply, for example, creative thinking to ambiguous problems and convey engineering solutions in economic terms. As you can see, the opportunity have some different steps. First of all, you have to identify an opportunity, investigate the market, and create a business model, and also test concepts quickly via customer engagement. And we just did it in the class. We divided two different groups, and after that we shared our ideas, and it was engagement. And for the design part, you should determine design requirements and perform technical design and analyze solutions. You can also validate your solution and results with different, for example, numerical simulations or using different commercial softwares. And for the impact section, you can, for example, validate market interest, or you can also build your own brand, or you can have your own business in the market. And that's all. Thank you.
Hi, everyone. I'll be talking about critical thinking analysis. So what's critical thinking? critical thinking is an art of thinking that is based on intellectual metrics or intellectual standard. And it can also be said that it's a thinking process in which you're able to analyze the system, assess the system, break it down to come to a judgment or to reach a decision. And this is a crucial skills for us to master as a engineer, precisely engineer, and be in anything in life, because it will make you to be able to study any body of content, whatsoever, any body of content in a non-trivial way. And the more we internalize this system, it becomes more part of us, and be able to come to a quality decision, make a good judgment, and solve any problem in life. So this critical thinking analysis is as a framework in which we need to follow, because anything in life, it has to be followed like a fundamental rudimentary. And for us to think critically, we have to ask, when we think, for instance, we think for a purpose, and this within a point of view that is based on assumption, and it often leads to implication and consequence. Aside that, we make use of model theories and concepts to interpret data, experience, and fact in order to answer our key question and to resolve an issue. So from this thing, when we think with the purpose, we make an assumptions. And for instance, as an engineer, most of the issues or the problem we solve outside this classroom or in the real world, they are not a close-ended question, or they are not a close-ended problem. They are mostly open-ended, that doesn't have a definite answer. And with critical thinking analysis, we're able to break down any problem to the simplest part and able to tackle them. So to make an assumption, we have to be able to justify why we make an assumption. Why do we make this assumption? We're able to be able to justify that. And our assumption has to provide an output in real world that is at least too close to reality, and create a workable solution from it. So I would like to say like a scenario in making an assumption, for instance. At times we have like a case of having a mathematical, maybe for instance, we create a mathematical formulation for like a model. This mathematical solution, it will agree with analytical solution. I agree that based on mathematical formulation, it might agree with each other. But when it comes to like experimental level, which is the real world thing, it might not agree. It might not be valid. That's why you call validation. We have validation test. Why might it not be valid? It might be due to one of your assumptions might be wrong. So that's why we're able to justify the assumption that you made. And then in tackling any problem, the most essence that we are here in the university is because to provide us information. We need more information, So to be able to solve any problem is left to us. It's left to our thinking skills. Even if you notice most of the courses we are given for us to solve maybe fluid mechanics problem, aerodynamics problem, in working the solution, you have to say, okay, well, problem statement, what were you giving, the property analysis and discussion. So we need to follow this rudimentary. That is, we have to generate a purpose within a point of view. For instance, consider a point of view like a user base. Me as a user, you have to think what user will be, maybe from manufacturer point of view, from like client point of view, and many things like that. So then from this, you have to break out from this international thinking analysis, or let me say critical thinking analysis, which is clarity. Your idea here has to be clear as much as possible. You have to be able to communicate your idea in a clear way to everyone. And aside, you have to test, how can we verify this thing that you're saying, this concept, how could you test it? And is it exact to details? Could you be specific on this idea? What's the relevance of these things that you are considering? And what is the impact in the society? And what's the central idea of this idea or of this problem? Because the problem might be so complicated in the real world that at times you have to solve one part, you have to streamline it, because at times when solving a problem, we need to move from known to unknown. So, and aside, what's the most difficult part of this problem or idea? That's why we consider the breadth and the depth, significance, and that's to be fair. And aside that, which I will add to it, when you follow critical thinking analysis, there will be more credibility in your results, you become more reliable, more practicable. And the whole essence of this is to be able to identify a problem long before it exists, create a workable solution for it. So thank you. Yeah, thank you.
Hello, my name is Mehdi. I'm going to talk about hierarchy of controls. So the question here is why that is important, why that is effective, because of actually safety and then risk assessment that is after that. Because it actually, it is because of individual health and all the factors impacting the health in your workplace. And also these controls, provide you with the most effective changes in your workplace and environment you're working in. Here at the top, we have elimination, that is to remove or minimize the hazard in your workplace. So for that, you should identify the hazards that you may encounter. For example, if that is a noise, a piece of equipment or device is causing, what you do is remove that equipment, remove that device, or you replace that, which would be substitution, which is actually replacing the hazard. Then we have engineering controls that are to isolate the hazard that you have in your workplace. Take dust as an example. In your workplace, what you do is, considering ventilation system, or if there's another hazard, for example, some of your ideas that, were designing something is actually a kind of engineering control. And then we have administrative controls that are to change the way people work. For example, you may use rotation to avoid assigning the same task to people that might be kind of, hazardous, might increase the risk, or those who are sitting at the desk for extended time. One outcome might be musculoskeletal, effect. So then at the end, we have PPE, personal protective equipment, like respirators, but that is the least effective because it is related to humans' behavior, because some may forget wearing mask or respirator or something. Yeah, that's all. Okay.
So the last thing here to mention is the risk assessment process that we're going to go through over the next couple of weeks. We're all going to get into projects, get into groups, and part of that will be doing a risk assessment of our own. They're going to look different depending on the project that you have. Some are going to be kind of on face value, very low or no risk, and those will be projects that you'll be able to carry out independently. Others are going to require a little bit more scrutiny, where we're going to have to put in place an evaluation with perhaps an environmental health and safety official, and then we're going to maybe have a risk control plan that involves clear identification of those risks, and then more importantly, how you're going to mitigate and control any hazards or risks. Generally, you'll be able to work independently on a moderate risk project within that risk assessment plan. A higher risk project, we'll know it when we see it, where we're a little more concerned about a particular thing, but we feel like we can safely work and safely conduct an experiment with appropriate risks and controls. That's going to have a little bit more formal oversight, including a schedule and supervised work versus unsupervised work for the others. So if we say you're in a high-risk project, we're going to expect, okay, we're going to meet with the instructor when we run that test on that day, and we're all going to show up and we're going to do the thing and make sure that everything happens safely. There's also the possibility that you propose something that's just too high of a risk for our organization's ability to manage and accept the risk. And so we call that here critical risk. And so those are unlikely to be within scope. You don't really know what risk level you're at. You have to use some judgment until you get through it. And we've had a number of projects that go through the first few weeks, get started, and then we realize, hey, that's not something that we're going to really be able to do. 2 years ago, we're not really going to be able to drive through Potsdam and hit all the potholes to see how our suspension responds. As much as that would be cool to characterize all the potholes in town, it just wasn't safe. Another one that we had to pivot away from, or just pivot to a different direction, was we were doing a bullet test last semester, and we had to reorient what we were going to do within the risk tolerance of the organization. It involved us printing some various bullet shapes that weren't real bullets, of course, and then doing a shock wave test to look at the flow over those bullets. So we have a risk assessment process. You're certainly going to see this in your industry. Yesterday, a student who came through 401, Brandon, came by and said, "Hey, Dr. Hoover, I wanted to tell you that I had an interview with Lockheed last week, and it wasn't going, it was up and down, but then they asked me about whether I'd done a risk assessment." And I said, "Oh, yeah, I've done a risk assessment." And he could talk about his risk assessment from this class, and then also what he had learned in 301, and he got the job offer. And so that's pretty exciting to see that little things like this can help you in your careers. The next assignment involves documenting all the things that we talked about here. And really the idea is we're trying to narrow in on this project, get groups starting to be formed, and get to a point where we're closer to a plan that we can execute. So under module 2, you'll see there is an assignment here, and the assignment has a template that's associated with it. This template, and then some reference materials, but the template is a Word document, and we can make sure that this is pulled up here. So the Word document starts with you filling out what type of experiment you have, your group name, if you have a group name, and if you have a group, you can fill that in. If you're still solo at this point and haven't formed with a group, go ahead and fill this out just on your own. And then the experimental test plan, short answer, kind of fill in the blank. Heilmeier Catechism questions, short answer, fill in the blank. Engineering skill set, analytical thinking guide, and risk assessment. You'll find that these methods are all basically asking you the same question from different angles. You'll also find that these are tools that are going to help you outside of this class whenever you have any kind of project that you need to propose, plan, or figure out what you're trying to do. So this assignment will be due for next lab, and that's going to be submitted individually. Although if you're working with a group, you can do it corporately with a group, just everyone has to submit individually. After this week, we are going to break into groups and have groups choose a section to be involved with. So then moving forward, if your members are not in this section, you'll all come to a single common section. And we'll just balance that out. Generally, it seems to work out naturally to be across different sections. But if we have everybody showing up in one section versus another, we might have to ask you to adapt a little bit. We're also going to pretty much have these sessions be about an hour moving forward. And most of the class is actually going to involve stand-up meetings where you're going to come up and you're going to present your progress, what you're trying to do, what progress you've made, what roadblocks you've hit, and what your next steps are. And then everybody Q&As on that. And that's been very helpful for getting projects through the semester to succeed. When we do that hour of our classes, the first part of class, the end of class will generally be an opportunity for you to meet with an instructor, meet with your group independently, or just to go on, and if you have other things to do, go on and do other things. We also are offering lab tours that are voluntary, and it's based on your own interest. Next week, we're starting in the BMCL, the lab over in camp. It's that big glass one. It's got lots of instrumentation, particularly mechanical characterization equipment that you might be able to use once you go through and learn about what's there, and then maybe incorporate that in your test if you have a relevant materials type of test. So that's it for today. Appreciate everyone's participation and hope you all have a great week. Stay warm.